What's up, guys? Welcome to the 4.1. This is the second part of this lesson where we're doing example number 2 along with the practice problems. All right, example number 2. What is it that they want us to do? Write an equation in slope-intercept form, the same thing that we did for the first part. But in this part, we're going to be taking this information from real-world scenarios. All right, so here we have a story. Let's go ahead and read it through. As always, I encourage you guys to stop it as much as you can and try to understand it on your own as much as you can. And then just listen to my voice whenever it is that you need clarification or to check your work. Marissa is baking a recipe that calls for her to turn down the temperature on her oven for part of the baking time. Write an equation to represent the situation if the temperature in her oven drops 25 degrees Fahrenheit every 30 seconds, and after 2 minutes, the temperature is at 350 degrees Fahrenheit. All right, so let's go ahead and I'm going to just read along with what this says as much as possible, and then I'll put my own twist to it. Step number 1, we want to determine a point on the line and the slope. So if you guys remember how simple the last example was, example number 1, the last video, we were given a point and the slope, and we were able to create an equation from that. Okay, now we have a story here. So where do we get our slope and our points from? So let me go ahead and read. After 2 minutes, the temperature is 350 degrees. That's what it says right here at the end. So we can say that x, because we need a point, right? We need an x comma y. We can say that x is minutes and y is temperature. So there you have it. We have a point. We have a point at 2,350. Okay. Now we need a slope. And remember that slope is not only rise over run, but also it's called what you call it? The rate of change is the rate at something at which something is changing. And this, or the oven, is dropping 25 degrees every 30 seconds. And that is a rate of change. That's how much it's changing its temperature, right? The change in X is 30 seconds, or we could say that how much is that in minutes? 30 seconds is how many minutes? That's half a minute. So we can put it as 0.5. Now, another thing that's very important, drops means negative change. So the change in Y, so my Y numbers, okay, my temperature has to be in minus 25. Okay, so what is, one more time, what is the rate of change? The rate of change is, remember the formula. Remember that the formula of slope was y2 minus y1 divided by x2 minus x1. That's called change, or the difference of the numbers when you subtract them. But we already know the difference. We already know the change, so we don't have to subtract numbers. Those numbers are already given to us. The negative 25 is going to be representing our y's, and the 0.5 is going to be representing our x's. And then when you go ahead and divide this right here, negative 25 divided by 0.5, that is going to give us negative 50 per minute. That right there is our slope. So our slope is negative 50. That should kind of make sense. So let me draw you a little picture. Imagine that we are looking at a coordinate plane where we only have positive numbers because it's a real world story. So we need positive numbers only. So we have down here, we have time. We have time. Time is passing. And what did the story said that we're doing with the temperature? The temperature has to be decreased. The temperature has to be going down. That's what the word problem said. So it only makes sense that the temperature starts at a high number and then it drops. Now, don't count my little tick marks. I didn't make a specific amount of tick marks, so don't quote me on my little tick marks here. But what I'm saying is we need a negative slope. We need a line that goes down, a negative slope. There it is, negative 50. All right. All right. So, now, the part that we need is the y-intercept. We need to find the y-intercept. We already have a point. We decided that 2,350 is going to be our point, and negative 50 will be our slope. So we have that and that, check. The next thing we need is the y-intercept. This is pretty much what we did last video, but we're now doing with the word problem. All right, so what did we say our y was? We said that we're going to be using 350. Our x, we said that it's 2. And then our slope that we found right now was negative 50. Okay, here it is. We go ahead and simplify. Negative 50 times 2 is going to be negative 100. And then we take 100 to the other side by addition, which gives us 450. This means that the temperature in the oven was 450. Okay. This means that the temperature of the oven was 450 degrees Fahrenheit when it was turned off. Okie dokie artichoke. So let's continue what it says. Write the equation in slope-intercept form. Now we already have everything we need, which is, remember, we only input the slope and the y-intercept. We leave the y and the x as y and x. And here it is. Our slope was negative 50. Our y-intercept is 450. Okay, and there you have it. Now, to give you an idea of what that means is that since our y-intercept is right here, that number right there is 450. So we started at temperature of 450. And our rate of change every minute that is passing, every minute, are we going by minutes? Well, the slope. Let me just go with slope right now. I don't want to take too much time right now because we pretty much finished the question. We are dropping at 50 degrees per minute. Okay. Okay. Let's go to our next one. All right, so this next one is a check problem. I want you to go ahead and pause it right now and try this on your own. It's great because even if you have pretty much zero idea, give me your best guess. So let's see how your guessing skills are. Go. All right, so let's talk about this. The total monthly cost of Aiza's, let's call it Aiza's, whatever. Gym membership increases by $5 per class she attends. After signing up for 4 classes, 1 month, her total cost is $49.99. Okay, which equation represents Aiza's total monthly cost, Y, after attending X classes? Now, for this problem, you have 2 ways to attack it. You have 2 ways to attack this problem. One way is to use what's given to you, guys. You already have the answers given to you. So what you can do right now is use the idea of inputs and outputs. They're already telling us that she signed up for 4 classes and spent $49.99. So if you were to go ahead and think of these functions, let's grab A. I'm just going to grab A, the first one. So imagine if I grab A and I write it as function notation like that, and then I put negative 5, and then I put parentheses plus 20, $29.99. Okay, so what if I put a 4 right here, because we take 4 classes, so 4 classes. If I put a 4 in here and I solve this, will my answer be $49.99? That is the question. Will this be true? If this is true, if my input and output are true, then this is the formula that makes that my input and output related to each other. If not, then it's wrong. All right. So you could do that route. You could see which of these makes, when we put in a 4, will get me a $49.99. Okay. And it should only be one of them. So don't worry about, oh, you know, can there be more than one? No, there should only be one of them. Now, what is another way that we can attack this? What is another way that we can go about this? Think about it for a second. Think about it for a second. We can go about it in the pretty much what we did before, where we can think of 4 and $49.99 as our inputs and outputs already. So she took 4 classes and paid $49.99. So think about this as your X and your Y. This is more of the algebra way. The other way that I showed you right now was pretty much using a little bit more common sense, making sure that if you take 4 classes, you pay $49.99. This is more of the algebra way, which is more mathy. But here it is. So they're saying that we have an X and a Y. We have a coordinate right here. And also they're giving us a slope, guys. They're giving us a slope here, a rate of change. So the rate of change says that it's going up by 5 every single time. So we need to look at our fives here. You know, we need to look at our fives here and go, which one here tells me that we're going up by 5 each time, up by 5 each time. So then you start to think, okay, that is -5, that is -5. So I'm thinking that these are wrong. My price is not going down every time I go, it's going up. So I needed to increase by 5. So 5 has to be positive. All right. Now, let's go ahead and say that this is my slope. Slope is 5. So let's create an equation where we write it in slope-intercept form. Y equals mx plus b. All right, let's grab the y that we had right here. And then the slope of 5 along with the x multiplied by 4. And then we look for our b. Okay. What are we going to get here? 5 times 4, we're going to get 20. Then we take 20 to the other side by subtraction. What do we get? Do you see, guys, that we now get $29.99 as our a positive $29.99 as our y-intercept, our b? So that is not $29.99. This 5 is negative. We're not supposed to be decreasing $5 every time we go to the gym. It's supposed to be charging us more. So no, this is the one that looks correct. And if you go ahead and do what I told you to do before at the beginning, just so you can have another alternate route. If you didn't understand what we did here, if you're like, whoa, I would have never thought of that, then just do our silly little easy inputs and outputs game. If you input a 4 in this, do you get an output of $49.99? And the answer is 5 times 4 is 20. 20 plus $29.99 does give us, what you might call it? The $49.99. So yes, this is the function that will give my inputs and outputs as they were given to me. All right. Answer is C. All right, guys, let's go ahead and jump to the example. Oh, wait. Okay, example number 2, example number 2. Okay, yeah. I didn't want to call this an example problem. That's why I had a brain fart. This is a practice problem, which is on page 213. So note that, 213. All right, let's see what's happening here. Carlos is jogging at a constant speed. All right, constant speed, meaning, you know, he does not slow down. He does not speed up. So it's the same exact speed. So he starts a timer when he is 12 feet from his starting position. After 3 seconds, Carlos is 21 feet from his starting position. Write a linear equation to represent the distance, which is in letter D, of Carlos from his starting position, T seconds after starting the timer. Whoa, there's a lot to talk about here. What I'm going to do, because my brain needs to see this. I need to see this. I'm just going to make, I'm just going to kind of see what happens here. Here is Carlos. I'm going to go sentence by sentence. He starts the timer when he is 12 feet from the starting position. So I'm going to call this right here start. And he doesn't start the timer until he is 12. So I'm going to say that this distance right here, this distance is 12 feet. And that was, he hasn't started the timer yet. So right now it's considered 0 seconds. So he's been jogging. I guess you can call this like the little warm-up section. And then here's where he actually starts the timer. All right. So he's right here. And then what happens? So let me just put feet. And then here's seconds. After 3 seconds, Carlos is 21 feet from his starting position. So after 3 seconds, he is 21 feet. All right, so if that's 12, let's make this 21 all the way over here. And that took him 3 seconds. So from here to get here, it took him 3 seconds, and that was 21 feet. Okay. Write a linear equation to represent the distance. Okay, so now we got to do a linear equation. All right, guys, let's go back to the fundamentals. A linear equation that we like, or that we've learned how to write, looks like this. Slope-intercept form. Y equals mx plus b. So two things that we need here. Two things that we need. We need a point. We need a point, and we need our slope. Okay, that's the first thing we need. So I ask you guys right now, do we have points to help us out right now? And the answer should be yes. The answer is, we have 0 with 12, and we have 3 with 21. We have those points. So what we can do is we can use any of those points, 0, 12, and let me make sure I'm using seconds as my x. Yeah, so my time is going to be x, and my distance is going to be y. Always, always, always use time as the x value, and then everything else as your y value. All right, so we have two options. We have these 2 points that I wrote right here on the side, and we have two options. We can find the slope by using common sense, or we can find the slope by using the slope formula. I'm going to do both of them, and I'm going to do them quickly. The one that I'm going to do first, which I know a lot of people might not like, would be the slope formula. Okay, the slope formula goes like this. Y2 minus Y1 divided by X2 minus X1. And now I got to look at these and call them which one is 1 and which one is 2. So I'll go ahead and call this one 1 and this one 2, right? So I have my X. Let me actually, now that I'm looking at these numbers, let me call this one 2 and this one 1. And you'll see why, because now I'm able to do 21 minus 12. I don't want to do 12 minus 21 and work with negative numbers. So 21 minus 12 and then 3 minus 0. Again, there's no wrong way. I could have selected my X1 and Y, and my point number 1 and point number 2 to be different, but nah, why? All right, so we're gonna have from 12 to get to 20, that's 8, so that's 9 right here. And we have 9 over 3 minus nothing is just 3. 9 divided by 3 is 3. The rate of change is 3. Now, if you didn't see that, let's go ahead and use common sense right now. Common sense. So, this is already the 3rd second. This is the 0 second. So 1 and 2. These are equally spaced out because look, you have 1 second, then 2 seconds. So how can you grab 21 and 12 and think about what needs to happen from here to here, from here to here, and then here to here, the same amount, so we get to 21. So we already found 3. So let's see if that's true. What's 12 plus 3? 12 plus 3 will give us 15. Then that's going to be 17, 18, 19, 20. Wait, 17, 18, 19, 15, 16, 17, 18. Whoa, where's my brain at? Okay, 18. My bad. I was thinking like odd numbers because of the 3. All right, so we got 12, 15, 18, and then 21. Yeah, that makes sense. So you choose whatever method you want. I was going with, my brain was actually going with this one at first. Because it's easier to see because I already had a drawing. All right, guys. So what do I have? I have points that I can use. I have points that I can use, and I already have a slope. The question is, which point do you use, Mr. C? Which point do we use? Guys, it doesn't matter which point you use because they both land on the same line. They are both going to take me to the same y-intercept. And you know what I'm going to do? I'm going to do both of them for you. Check it out. I'm going to go ahead and do y equals mx plus b, y equals mx plus b. You can do one of them. You can do both of them. I don't care which one you do, but I'm going to show you that you can use either this x comma y or this x comma y. Obviously, we have the same slope of 3. All right, so on this side, I'm going to go ahead and use the 0, 12. So my y is 12. A slope of 3, an x of 0, and then we're looking for b. Here we have a y of 21, a slope of 3, an x of 3 again. We're looking for the y-intercept. All right, 3 times 0 goes away, so you get nothing here. So it's telling me that my y-intercept is located at 12. What's going to happen here? 3 times 3 is 9. We take 9 to the other side by subtracting. And we get 12 is equal to B. So it doesn't matter which point you choose. They are from the same line. They will tell you, they will point to their y-intercept. Now we have everything we need to create our equation. Y equals my slope of 3, x, and then my y-intercept, we said that was 12. Here's our equation. That is our equation. If we go up here and I tell you how our equation could be made up, you're going to be like, whoa, you spent all this math. You did all this math for that equation. Check it out. You ready? Watch. Where are you, answer? I think the answer is here. Okay. So here's the answer. The answer is we actually started at 12, right? We start at 12 and then we are adding 3 each time, aren't we? Look at what happened here. We started at 12 and then we add 3 each time. So we could have actually just stopped right there. And by when I say time, just put T for seconds or minutes, whatever it is that we were talking about, seconds. So T seconds. Why am I doing this? Why did you do this route? Why did you do all that work? Because you needed to see it. If you did not know that you could do that easy thing that I just told you right now at the end, then I need to show you the long route for you to see, for you to be able to see once you see a question like that yourself. Okay. Okay. Don't hate me. Hate me. I can care less. Example number 3. This is on page 211. Flip your page. All right, people, here it is. Write an equation given 2 points. Write an equation given 2 points. Fun fact, we just did that with the previous question. In the last question, this kid was walking around, jogging around. We actually found 2 points, or we noticed that there was 2 points given to us. And from there, we did everything. So what do we do when we have 2 points? Well, when we have 2 points, find the slope, because with 2 points, you can find the slope, put them in the slope formula. Okay, so you could see that they're going to grab their y's, 1.6 and negative 0.7, and subtract them at the top. And then they're going to grab their x's and subtract them at the bottom. And then they're going to simplify, aka divide, and they're going to get 2.3 divided by negative 4.6 will give them negative 0.5. That right there will give you your slope. Now, what do you need? Well, to find our y equals mx plus b, we already have 2 points that can help us with the x and the y. We already have 2 points. We have that one and that one. We also just found the slope. So our last step right now is use all this information to find this one. Once we find that, we can create our equation and we're done. Finito, finito. So here it is. Use either point. It doesn't matter which point you use. I proved it to you in the previous question. It doesn't matter. All right, so you can see here how they inputted these numbers in there. Our slope of, okay, here we go. Our slope of negative 0.5, the x value of negative 3.4, and the y value of 1.6. When you solve that and you take 1.7 to the other side by subtraction, we get a y-intercept of negative 0.1. And then we just write the equation. And voila, we are done. Substitute your slope with the slope that we found and substitute the b or y-intercept by the intercept that we found. That's it. We're done. This is our equation. All right, let's go ahead and do a little check problem. Pause it right now. Try it on your own. Let's do it. All right, here we go. We want to find the equation of a line that goes through these 2 points. The equation of a line that goes through these 2 points. Okay, so the first thing that we want to do is we want to name these points. We want to name them x1, y1, and x2, y2. Does it matter which one you name what? No, it does not matter. We've already done this, guys. You know this. We've already done this. So let's go ahead and do our slope formula. We need to find the slope. The slope formula is your y subtracted divided by your x's subtracted. It is very important, very, very important that if you write y2 at the beginning, you need to write x2 at the beginning. You got to line them up. So your x1 and y1 and the x2 and y2 need to be matched up like this. Okay, that's very important. If you mix those numbers up, your answers will be wrong. Okay, so my y2 is negative 12 minus my y1, which is negative 3. So I have to put minus negative 3 because this subtraction is already there. So we need to put minus a negative 3. Continuing, divided by my x2, which is negative 7, minus a negative 5. Okay, something that we need to talk about one more time, every single time we need to talk about it, is that a minus negative is actually the same thing as adding. Once again, a minus negative is the same thing as adding. So see it that way, and it's going to be a lot easier. Negative 12 plus 3 will give us negative 9. And then we got negative 7 plus 5 will give me negative 2. What is that going to give me for my, what am I? Oh, here it is. So let's bring the m down. So m, or the slope, is going to be negative. Oh, no, sorry. Negative divided by negative is a positive. So we have a positive 4.5. Cool. Okay, now we have y's and x's to work with. We have y's and x's to work with. We have a slope to work with. The only thing that we're missing right now is b. So let's go ahead and do that right now. Once again, choose any point that you want. I always like working with easier numbers. 5 and 3 seem a lot easier than a 7 and 12. I don't know. My brain tells me that the math will seem easier with those numbers, so I'm just going to with those numbers. So I'm going to go write negative 3 as my y. My slope is 4.5 multiplied by x, which is in this case negative 5. Add b. All right, so we got negative 3 equals 5 times 4.5 will give me 5 times 4.5 will give me 22, and it's a negative times a positive, so it's a negative 22.5 plus b. Okay, and then we go ahead and take take the 22 to the other side by addition. Man, I hope I didn't make a mistake here. So we got 22.5, and now we need to take 3 away from that. That is going to put us at 19.5. That is what b equals. All right. Lord, please make sure these numbers are right. I mean, if not, whatever. This is going to be a great way to do a little error analysis. But let me just write everything together. So let's go ahead and write the full equation. The full equation is going to be y equals my slope of 4.5, x, and my 19.5. All right, let's see. Okay. So 9 divided by 2 is 4.5, and the 39 divided by 2 is 19.5. Good. All right, we did this right. All that happened was that we just put it in decimal form. It doesn't matter. It's still fine. Once again, grab that and divide it so you can see that it's 19.5. Cool. Done here. All right, guys, let's go ahead and put it into practice. Try it on your own. Do not wait for me. You got this. Okay. We're going to do something a little bit different right now. It's a little bit different. What I'm going to ask you to do, I'm not going to sit here and do all of these. I am not. What's going to happen right now is you're going to see all these answers. Here's the answer for number 11. Y equals negative 4. Here's the answer to number 12. Here's the answer. And remember the 1/4, you can, or any fraction, you can see it as a decimal. So make sure you divide them if you're writing stuff in decimal form. Okay. What I want you to do is ask me in person for clarification. Okay, here are the answers. Hopefully you already completed them, or if you didn't, try to work your way towards these answers. Cool. I'm going to go ahead and stop this video right now. So peace out.